Hello, I'm Karen Blako, Food Safety Specialist from Commercial Food Sanitation. Welcome to our CFS online course. In this module, I'm going to share with you how to control pathogens through environmental monitoring and hygienic zoning. First, we will discuss how to identify and detect pathogenic bacteria through a robust environmental monitoring program. We will then review how hygienic zoning will help a facility mitigate the risk. This will lead into barriers and hurdles as controls between the different zones. Here is a list of pathogens of concern and their sources. Salmonella can survive for a long time in dry, low moisture conditions and grow easily in products such as peanut butter, dairy, chocolate, and baking products. Listeria monocytogenes can survive in cold and wet environments, such as fresh-cut fruits and vegetables, meat products, and dairy products, as well as processing facilities. It can also be found in wet and cold environments in dry processing facilities, such as a cleaning room, a spiral cooler, a cooling tunnel, etc. E. coli 015787, which comes from animal feces, can be associated with products such as meat, fresh-cut fruits and vegetables. Common sources of contaminations of pathogens include raw materials, such as agricultural products, raw meats, seafood, and live poultry. These materials can be naturally contaminated with pathogenic bacteria. Employees can also be a source of contamination. Employees may travel to other places before coming to work. Contractors may work in a different type of factory before moving into a food factory. Equipment and infrastructure themselves do not support microbes. However, if not designed properly, they can become a protective shell for pathogens to thrive. Pathogens are invisible enemies. Factories should therefore design and use an effective pathogen environmental monitoring program to find harborage areas where the pathogens grow and then eliminate them. The goal is to seek and destroy. This will identify pathogen-positive locations, as well as lead to identification of root cause, enabling corrective and preventative actions to eliminate harbor sites going forward. Where do you think you are most likely to find pathogens in a food manufacturing environment? A list of potential locations include transitions between raw or ready-to-eat areas, walls that are potentially damaged, floor cracks, drains, door seals that are not intact anymore, all of which can trap soil, water, and of course, bacteria. Equipment can harbor pathogens in, for instance, hollow rollers, sandwich joints, switches or control buttons, or hollow framework that is not hermetically sealed or damaged, wheels, legs, and many other niches where bacteria can harbor and be allowed to grow. When developing an environmental monitoring program, equipment and infrastructure are divided into zones according to the proximity to the food contact surface. The model shown on the slide, which is initiated in the US meat industry and now widely used throughout the food industry. Let's look at the monitoring model. Zone 1 refers to food contact surfaces, for example, tools, conveyor belts, pipes, or operator hands. Zone 2 refers to non-food contact surfaces that are adjacent to Zone 1, such as bearings, equipment panels, aprons, etc. Zone 3 refers to the equipment and facility within the production area, such as the floors, walls, floor drains, or lower framework of the equipment. Floor drains are important as they can harbor or collect pathogens and should be included in the pathogen control plans. Zone 4 refers to any other area in the factory outside of the production area, such as changing rooms, corridors, warehousing, maintenance shops, etc. A robust monitoring plan includes all zones with an emphasis on locations as determined by a risk analysis on the harborage and high traffic areas to aggressively seek and destroy the pathogens. Products and processes have different levels of risk and should have protective control measures in place for each area, a concept commonly referred to as hygienic zoning. They may be different in each facility based on product and process risk. This image is intended to represent the concept, a layer or zone of facility, using a castle and a water channel to simulate protection of high hygiene or a ready-to-eat area. For example, the castle represents product or a food contact surface and should have multiple layers to support the highest degree of protection. The walls, trees, surrounding grounds provide other layers, as do the water and the forest. Each barrier is designed to protect the interior, higher hygiene zones. Different companies may have different terminologies for zoning. The name may be different, but the concept is the same. Like the pyramid, the top section needs the highest degree of protection. All the layers below support the top. Tighter control towards the bottom will strengthen the top. Hygiene zoning models based on risk include non-production, low risk, medium risk, and high risk areas, which may be referred to as ready-to-eat or high hygiene areas. Non-production areas require pest control food defense measures. Low-risk areas may include raw material storage and require pest control food defense measures as well as basic GMP compliance. Medium-risk areas require enhanced processes to control the presence and movement of pathogens. These can include fruit and vegetable washing locations, where product will be exposed to the environment or touched by operators. While processes do not eliminate pathogens completely, there should not be any secondary contamination or transmission. This area should ideally be separated from the ready-to-eat or high hygiene, as well as raw agricultural product handling locations. Ready-to-eat, high-risk or high hygiene areas require the most protection as there are no further lethality steps. They should be fully separated with stringent controls. The blue dots in the picture represent pathogens. Our priority is to separate processing areas with the different degrees of risk. We know that pathogens may be present in raw areas, as they may be introduced through raw material. It is critical that they do not contaminate ready-to-eat or high hygiene areas. There should ideally be physical separation between these zones and safeguards in place to ensure to address any potential interaction between, for instance, people, logistics, airflow, etc., to ensure that pathogens are not introduced in the high hygiene areas. Control should be strengthened when moving to higher hygiene zones through transition areas. The management of transition areas should be conducted in accordance with the risk analysis and be focused as necessary by the risk. For example, employees should wash and sanitize their hands going into the facility, as well as when going between zones. In more sensitive areas, scrubbing and sanitizing of footwear is another control measure that can be taken. An airlock chamber is a buffer room set up between high hygiene zones and other zones. It contains two doors that cannot be opened at the same time in order to fully separate traffic and airflow. People movement and any logistic movement between low hygiene to high hygiene areas or raw and ready-to-eat areas should be fully understood and controlled. Waste, air, and packaging material flows should be from high hygiene to low hygiene areas. It does not have to be complicated. However, especially for older facilities, it can be quite challenging to control this movement in order to eliminate cross-contamination. To summarize, a sound environmental monitoring program is designed to seek and destroy pathogens. Hygienic zoning is a critical step to protect your product from contamination. And where a physical separation is optimal, it might not always be possible. Hurdles and controls are important barriers to protect the processing area and protect the product. Thank you for watching and listening. We hope that you can share the knowledge that you've learned with your colleagues and put it into practice in your daily work. If you have any feedback or questions, please contact us through the provided email address.